So now we want to put the coefficient of determination together with everything we've learned in all of Chapter 4 into one big example. So the following data set shows the relationship between the explanatory variable of a state's high-speed internet rate, so this is x over here, and their teen birth rate, which is the response variable. It's very nice of it to tell us that, although we could have guessed that because the explanatory is on the left, response variable is on the right. All right, so let's find the following. So it wants us to find the correlation coefficient, which is r, and it wants us to find the coefficient of determination, which is r squared. And looking down, we also want to find the regression equation, which will be y hat is b plus ax, right? Where we have a number for b and a number for a. So all of those pieces we want to put together. Okay, so we can find all of those with StatCrunch. So the StatCrunch path through all of this chapter is stat, regression, simple linear. And so that's how we're going to find all three of those pieces at once. And it didn't ask us, but we could also find the sample size, which is how many there are, and other pieces of information as well. Okay, so first thing I'm going to do is I'm going to go find this data set in my data set sheet. So this is the internet versus teen birth rate. So I'm going to click on this. And there we have it right there. So this is the internet versus teen birth rate. So we're going to go to stat, regression, simple linear. The x variable is always the one on the left, so internet. And then the y variable is the teen birth rate. And then we say compute. Okay, so again, remember it gives us all sorts of info. We don't need all of that info. We're just going to kind of look at this block right here. So it's telling us the y, we chose the teen birth rate as the y, that's the response variable, the x, which is the internet rate, and then right here is actually the regression equation, and then there's the correlation coefficient. Our sample size was 20, so that's nice to know, and there's r squared. So the first couple questions for A, we know that r is negative 0.733, and we know r squared, which is the coefficient of determination, is 0.537. Then we also know teen birth rate was the y, and teen birth rate is right here, so that's y. So y hat, for letter E, y hat is 182.446, take away 1. Right, because take away because there's a subtraction right there, 1.857 x, because the x is the internet. Now remember, if you don't like the y and x being written out in words, you can switch them. You can make it so instead of internet, you click up here in the gray part and say x, and then move to the teen birth rate in the gray part and say y. And then if you refresh, it'll actually write it more like an equation. So if that makes you happy, then feel free to do that. Okay, so we just got a bunch of answers. Right, from StatCrunch. We know that the r is negative 0.733, we know the r squared is 0.537, and we know that this y hat equation right here, we have a number minus a number x. If you want to write it in the algebra way, that's fine with me, and probably fine with your instructors as well. I'm just not going to work from that, so it's negative 1.857 x plus 182.446. You do not have to write that if you don't want to. It's just some students are more comfortable with that, especially if they've been in algebra classes. Okay, so I have to get rid of this piece right here. There's nothing to circle. I changed this from a circling to writing it. So strength and direction. So we would look at our R value, and we think about the strength and direction from this table. So our R value is negative 0.733, which is right here in the moderate negative section, right? Because it's between negative 0.5 and negative 0.8. So our strength is moderate, and our direction is negative. All right, what about interpreting the coefficient of determination? Well, there's a very firm and rigid script for that we learned in section 4.3, this section. So we would change our r squared to a percentage, and then we write the rest of the script. So let me write that down, and you write it as well. There, I wrote it down on my paper and actually moved this over just a little bit so we can kind of make sure we can see this. So we change our r squared from a decimal to a percent by moving the decimal 2 spots over. That's what it means when it says multiply by 100. That means move the decimal 2 spots to the right. Right? This piece right here is this piece right here. Okay, so we're going to move that 2 spots over. So that's 53.7% of the total variation in, and then we just have to say what the y variable was. But we labeled it, of course, for ourselves. It's right here. It's the teen birth rate, right? That teen birth rate is the response variable. So that's the y. So we would say 53.7% of the total variation in teen birth rate from state to state is explained by the least squares regression line. Done. Now, what was the slope? Well, the slope is always the number that's multiplied by the x. Whether it's in this form or this form, it's the one that's with the x. So it's negative 1.857. That is the slope. Now, to interpret it, we want to use the script for interpreting slope that we learned in section 4.2. Right? If our x in words increases by 1, then y is expected to increase or decrease by approximately a. So I'm going to write that script out with all the blanks, and then we'll fill it in. Okay, so here's the script in all its glory. So if the x, which let me write that in a different color. Let me write it in purple here. So if the x increases by 1. Now what was x? So if I go back up here, x was the internet, the high-speed internet rate, right? That's x. So if, and it's technically of a state, so a state's internet rate or a state's high-speed internet rate, depending on how much room you left yourself to write, internet rate increases by 1, and then this was the x, this will be the x unit. So the x unit, you have to go back up. Now it's not in the table on this one. It's right here. This is the x unit, so it's percent. Right? It's technically a percent of households, but we'll just say percent. Then the y, well, the y, we already said, that was the teen birth rate. Or I'm going to say the teen birth rate, just my English is not as terrible. The teen birth rate is expected to, all right, we have to make a choice here. So we have to choose increase or decrease. And we're going to choose decrease because it's a negative slope. Since our slope is negative, it's a negative relationship, then we'll use decrease. By whatever the slope number was, so 1.857, and then it's births per female. Oops, I'm out of space. Let me rewrite that. There, I managed to put it down over here. So then the teen birth rate is expected to decrease by 1.857 because that's your slope number, right? So 1.857, and then what? Well, the unit on this one's a little bit more. So we go back up. The unit is right here. It's births per 1,000 females. So this is the Y unit. So we'll write that in. Births per 1,000 females. These are teens, so females aged 15 to 19. Right, so that's our Y unit right there. All right, that was a lot. What's the y-intercept? Well, the y-intercept is always 0 something. So 0 what is the question? Right? It's an ordered pair, right? So we have to go back and look. The y-intercept is always the number that's not with the x. So it's 0 and then 182.446. Now that does not make any sense. So that's why we have to explain. So when we look for why it doesn't make sense, the most likely culprit is the 0, right? It's impossible for the x to be 0. So we have to explain what that would mean with words and context. So x was the internet rate. for a state in the US, right? In 2021. So there is no state in the US in 2021 that has a high-speed internet rate of 0. That's not a thing. So that's what we have to explain down here. It's impossible for a state, it's possible for a US state to have an internet rate of 0. Yet again, it's the x equals 0 that makes no sense. This is the part you've got to watch out for, right? Because, and I'll just start it. The x equals 0 is what makes no sense in this case, and that's usually the case with these problems.